Now, let us go through an example of disadvantages. The first advantage, what I stated earlier in the previous session, was we don't need to go through the loops to perform the vectorized operations. For an example, uniformly you just want to increment the values of the array. In what was the actual way you will do it? Obviously, you're going to take a loop through which you will be able to update the array, right? But here in Numpy, we will be able to update all the elements of the array by using a single vectorized operation. How? Let us understand. Let us take a list 1, 2, 3, 4, 5. Here I just want to double this list. For that, what I'll do is x into 2 for x in the list. This is a loop. What you actually are watching on the screen is a loop. Okay, so this is a loop. This is a loop. Okay, for the loop, obviously it just takes a lot of time. Using a Numpy array, what we'll do is, I just have created a list. The list name is first. What I will do is, I just still pass it to the Numpy array. Now I will take an array. This array is a Numpy array. I just can create a list. That list can be converted to as a Numpy array. What is the way? Simply, I just need to take an identifier. Identifier of an array is ARR. AR is equal to NP. From the NP package, we are using array function. What is the array function? Array function will create an array by using the passed parameters. Here, what is the passed parameter? Passed parameter is first. First is the list. List has actually been, see, this is LST, not first. LSD is a parameter that is being passed to the array function. This array function is going to convert this list LST into a single array. The earlier, which actually was a list, which actually was scattered across the memory, will be collected together and will be organized as a single array right now, right after you use the array function. So creating array, the way to create the array is just use an identifier, after which you use NP. Okay, NP stands for Numpy. NP.array. Array is the function which converts the given parameter into an array. Now LST is the given parameter, it will get converted to an array. Now what I need to do is, I need to take another variable which is array double. Is an identifier through which what I'll do, I'll simply use a function ARR into 2. I just did not do anything, rather ARR is an array. When you refer ARR, what will be referred? The total elements of the array actually is going to be referred in this case, right? ARR into 2 meaning all the elements of the array will be multiplied by 2. As simple as that. Now the result will directly be passed to ARR double, which is the other identifier. Okay. Now by like this, we will be able to perform any complex operations. We also can use vectorized operations such as this. Earlier in the list, we just are using a loop. This is a loop. But here we are not using any loop. We will be able to perform the operations very, very simply indeed. Yeah. Lists are inherently one-dimensional, though they can be nested or create 2D, 3D structures. However, operations on such structures are quite cumbersome. Now, what is the list? List is going to give you only 1D vector, simple, a vector of 1D, a single vector of elements. It's a 1D array. Now, but whenever we deal with the data set, whenever we collect the data set, first of all, we should be able to convert the data elements into 2D or 3D arrays. List doesn't support 2D or 3D arrays. Still, we'll be able to convert this list to 1 or 2D arrays. But the problem is, we just need to perform huge operations on this. We should be able to concatenate them. We should be able to collect them. There are a lot of complex operations actually required to convert this list into 1D or 2D arrays. This process is quite cumbersome. We just require to write some additional functions through which we'll be able to convert the list into a 2D or 3D array. But within Numpy package, you don't need to do anything. You should be able to call some inbuilt functions. You should be able to call some inbuilt functions. Directly, you'll be able to create 1D, 2D, 3D arrays by using one object called ND array. There is one object called ND array. ND array is the main object of Numpy package, by using the ND array object, you will be able to create the array that belong to any dimension. You'll simply be able to create. That's the advantage over the list. Now, let us have a look at import numpy as np. By using np keyword, we'll be able to call any of the package, any of the function within the numpy package. Now, what I'll do is, by using np.array, what I'm doing, I'm creating an array, 1, 2, 3, 4, 5, 6. Okay, here, I have created a two-dimensional array. If you want to create one-dimensional array, you should be able to create by using only one set of squared brackets. If I say 1, 2, 3, it will be one-dimensional array. But if you want to create a two-dimensional array, what you just need to do is just put a comma, 4, 5, 6, and enclosed with a upper brackets, upper set of angular brackets. That is going to create a 2D array. Okay, now here np.array. What is array? Array is going to convert, array function is going to convert the given parameter into array. Here the given parameter is two vectors. One vector is 1D array. You just have collected two vectors together. That will be a 2D array. Now here I just have created one array which is of a size 2 into 3. I have 2 rows and 3 columns. Okay, so that's how we can create an array. When we simply print the array, what will get printed? The output. When we print the array, it will get printed. The printed array will be equal to 1, 2, 3, 4, 5, 6. Okay, but when you want to print a shape, you can use np.shape. If you say matrix.shape, what is matrix.shape? Matrix is the array. If you say matrix.shape, what will be the output? The shape of the matrix will be the output. Output will be 2, 3. Now let us go through the other functions, other built-in functions of NumPy. NumPy also provides you the functions such as Fourier transformation, mean, median. And if you want to calculate Fourier transformation or mean or a median, what you generally would do in a list, you just need to write an additional function, or you should be able to add the packages, include those packages to this Python. You should be able to call those packages from the Python library, or also you just will be able to add some additional packages. But here NumPy is going to provide you with an inbuilt function, with all of the inbuilt functions to calculate, such as mean, median, standard deviation, Fourier transformation. In the previous session, in the first topic, what we discussed about importance of mean, median and a standard deviation, right? The midpoint of the data set. So here, in order to calculate this mean, median or standard deviation or Fourier transformation, we will be able to, in order to calculate this, we'll be able to access the inbuilt functions of NumPy. For an example, array is equal to np.array 1, 2, 3, 4, 5. So this is the array that I have created. Now here I just want to create the mean. I just want to calculate the mean. How do I be able to do that? Simply, I just need to use np.mean. np.mean is a function. Mean is a function. Mean is a function which is going to calculate the mean of the given parameter. Okay, here the mean will be collected, the mean will be calculated for 1, 2, 3, 4, 5. Here we just directly passed an array to calculate the mean. In the mean function, we directly pass the array. Right, then this mean function is more than capable of calculating the mean and produce the output and return the output. Here, similarly, there is something called standard deviation. For the standard deviation, it is called std. Std function is going to calculate the standard deviation of the passed parameter. Right? So here, I'm going to calculate the mean. I also am going to calculate the standard deviation.